Today in class we're going to do an activity where we practice all the topics that we've covered so far this chapter, but we'll start with a quick warm-up. So for the warm-up, Henry opens a bag of M&Ms and he starts to eat them. After 2 minutes, Milo asks Henry if he would like to share with him. Henry counts his M&Ms, realizes he only has 53 left. He decides he does not want to share any with Milo. After 10 minutes, Greta notices that Henry only has 5 left and asks if she can have some. Again, Henry declines. If Henry was eating his M&Ms at a steady rate, write an equation between the time gone by t and the total M&Ms he has left, m. Okay, so if we take a look at this, we're trying to figure out what is the slope. If this was linear, what is his rate of change? How many M&Ms is he eating per minute? So to do that in a table, we can assign, well, there's a few ways that we can do that. We can say, all right, slope. Let's talk about the idea of slope. Slope is y2 minus y1 over x2 minus x1. It's your rate of change. In a table, the independent variable is your x, so here time would be independent and M&Ms would be dependent. And again, we would just be subtracting, so I think it will help me at least to label these. You can do this several different ways. So I'm going to call my first coordinate 2, 53. So after 2 minutes, he's eaten 53 M&Ms. And then after 10 minutes, or he hasn't eaten 50, he has 53 M&Ms left. And after 10 minutes, he has 5 M&Ms left. So if we plug in to slope formula, oh, this should be y2. Okay, so here we go. y2 is 5, and x2 is 10. And then we'll subtract y1, and we'll subtract x1. So this will be our rate of change. So 5 minus 53 is negative 48. 10 minus 2 is 8. And we'll get negative 6. All right, so let's talk about what does slope stand for in this situation. And it would be he's eating 6 M&Ms per minute. So we look at how much time has gone past. So this would be negative 6 over 1, which means 6 M&Ms eaten per minute. With a slope of negative 6. Could you figure out how many M&Ms were in the bag before Henry started eating them? Again, several ways to figure out these problems. So one way, since we know it's linear, is we can look back at our table and think about going backwards in time. So let's say we want to figure out how many he started with. That's time 0. So we're going to count backwards. So we're going to go backwards 1 minute and then 0 minutes. And again, we know that going forward, we're subtracting 6 per minute. So if we go backwards, we'll add 6. So we can take 53 and add 6 once, and then take that answer and add 6 again to get how many M&Ms he started out with. So essentially, it's taking 53 plus 12, because 2 minutes have gone by. And if we do that, we get 65 M&Ms at time 0. So we could say 65 M&Ms. By using the table and counting backwards. We could use a linear equation, right? So if we have the number of M&Ms left equals the time that has passed times the slope plus a y-intercept b. So here's your linear equation. It's like y equals mx plus b, but we know the slope. And we could pick a coordinate to plug in. So I'm just going to pick one of these. I'll just pick this guy. So we'll plug in 10, 5 as our x and our y, and I'm going to plug that into this equation right here. So we have 5 equals 10 minutes has gone by times our slope, negative 6 M&Ms per minute. We're solving for the starting value, which is the y-intercept, or b. Okay, so then algebraically we could solve this. 5 equals negative 60 plus b. To get rid of a negative 60, you would add 60 to both sides. And if you do that, we get our same answer, which is 65 M&Ms per minute. So again, we can use a table, find the slope several ways. If we know the slope, we can use that to figure out the starting value. So today, you're going to be working on this and similar ideas that we've looked at throughout the last 3 days. So we'll be doing an activity in the room where we'll read certain situations and see if we can solve them.